So CRS can interact with the challenge project in many different ways, everything from just reading the text of the source code all the way to exercising and running the code itself. Now, in AIxCC, in order to score, a CRS has to be able to find a vulnerability and exercise it via a harness. A harness is a special program that allows an input to be received and then exercise a particular part of the challenge project code on that input. So if we were to look at the challenge project altogether, in this visual, we have all of these green nodes, around 11,000 functions that make up the TICA challenge project. And so this graph shows you all of the connections between these functions, as in one function can call another, and how you can reach all of these different nodes. So a harness is going to expose part of this functionality. About 1,000 of the 11,000 total nodes are reachable from this one particular. And so a CRS has to generate an input that when it's fed to the harness will reach the vulnerable location and exercise that vulnerability. So if we were to look at that, going from the entry point of the harness all the way to where a vulnerability is exercised, that's going to be highlighted in red here. And so this shows visually a path from the entry point on the left through the code all the way to the point where the vulnerability triggers a sanitizer. The sanitizer is a special instrumentation that detects when particular things happen, like a buffer overflow or a memory access out of bounds. And so triggering a sanitizer is a proof of vulnerability, which is part of what a CRS needs in order to score. One of the ways that things can go wrong with a CRS is that it might be able to find a vulnerability in terms of, I think this line of code is vulnerable, but it doesn't know how to get there. Or it sends input, but the input reaches that location and doesn't trigger the vulnerability. Now, the CRSs should be able to run the code themselves and see the sanitizer is triggering or not, but there's often a lot of difficulty in just figuring out how to reach the vulnerable location from the entry point. There's a number of techniques that CRSs can use to discover these paths to the vulnerable location and try to trigger the vulnerable location. But one of the things that's interesting about AIxCC is it's not just about generating input that triggers a crash or a sanitizer, but they also have to identify that line of code, and in the history, the commit history of all of the changes that have been made, they have to be able to identify when that vulnerability was introduced. So in the case of TICA here, there's something on the order of 1,500 files, source code files in TICA. And if you were to look at the regular version of TICA on the internet, there's something like 8,000 commits, 8,000 changes that stacked up to create the current version of that code. So this version that we're looking at has all these vulnerabilities. The question is not just how do you trigger it, but when was it introduced? So on the other hand, if we think about how humans think about code, we read it top to bottom. And if we scan this piece of code here, looking at these words that are highlighted in green, you can see that this harness function we talked about calls other function. And this is how the input is going to flow through and reach these other interesting parts of the code. Some of these functions, like set netlink packet, are going to be interesting. So if we go to where it's defined, we can read this code. Now, that jump that we just made from one to the next, that's what's being shown in the call graph. So the call graph gives us that top level view. And it's really interesting because CRSs don't think about code the way that a human does. They can process it and exercise it, but really how they go from this starting point to finding the vulnerabilities is going to be one of the coolest parts of AIxCC.